the twin prime conjecture and random sampling. My motto: plain honesty, simple truth, easy understanding, the joy of finding things out for yourself. If you go to Wikipedia and look in the Wiki Layers section, which is where you will find articles written by mathematicians for mathematicians, and search twin primes, you will find that the second paragraph states, twin primes become increasingly rare as one examines larger ranges, in keeping with the general tendency of gaps between adjacent primes to become larger as the numbers themselves get larger. However, it is unknown whether there are infinitely many twin primes, the so-called twin prime conjecture, or if there is a largest pair. The breakthrough work of Yitang Zhang in 2013, as well as work by James Maynard, Terence Teo and others, has made substantial progress towards proving that there are infinitely many twin primes, but at present this remains unsolved. I will now demonstrate that this statement is false and has been presented in the way that it has in order to deceive and baffle the majority of us who in the main are not well versed in the understanding of large and infinite numbers, in order to glorify themselves and their so-called achievements in the eyes of the public. At the end of the article you will find in the list of external links a link to the first 20,000 twin primes. Download and analyze it, and you should easily find the two following salient and pertinent facts. 1. The actual number of twin primes increases greatly for every tenfold increase in the size of the number field, and 2. Constantly decrease as a proportion of that number field. This is shown in the table below. I extended the number search for twin primes to the first 450,000 in order to include all 8-digit twin primes, and then to 1,000,000 to include some 9-digit ones. These results are again shown in the table below. Note that after 1,000,000 twin primes, 569,689 of them were found in just 25.24% of the 10 to the 9 number field. There's still a lot more to be found. So their abundance, which from our small sample shows them to be ever increasing for each increase in the size of the number field, is the significant fact, and not their rarity, as some would mislead you to believe. It has been clearly demonstrated that twin primes are an ever-increasing abundance for every tenfold increase in the size of the number fields, so are therefore infinite in quantity, QED. Corollary: random sampling with a simple polynomial. In September 2019 I uploaded the simpleton's proof of the twin prime conjecture using real-world mathematics, in which I presented a cubic polynomial that could be used to find twin primes, and the full implications of which I only fully truly realised when I embarked on this simple but obvious demonstration. The polynomial jumps through ever-increasing number fields in ever-increasing size of jumps, and we check for twin primes at each jump. So the process is purely random as to whether we get coincidence with any twin primes or not. So discovering scarce twin primes should be virtually impossible if what we have been led to believe is true. So let's see what we get when we carry out the search. Bingo! The screenshot shows the end results for a 100,000 random jump search, in which 869 twin primes were found, which extended into the 10 to the power 19 number field, resulting in 19-digit primes. The search was extended to 1 million jumps, during which 6,480 twin primes containing up to 22-digit primes were found. The results gave the following analysis shown in the table below. So yet again, the table of results for the random sampling trial show the twin primes to be approximately doubling for every tenfold increase in the size of the number field, in keeping with what we have already found, and so confirms what we have already stated, which is that the twin primes are infinite. So once again, QED. To finish the presentation, this screenshot shows yet bigger twin primes due to variable changes in the polynomial, so the process is potentially unlimited. That's all, folks. Hope you enjoyed the maths, and thank you for watching.